Combinatorics is just a fancy word for, it's a way of counting the number of ways an event can occur. Now, up until now, we've just counted up. We've just added up the number of ways. We've put the sample space down, and we've just counted up the way a particular event happens and then put it over the total number. So there are other different techniques that happen in combinatorics that allow you to do it a little bit quicker than just counting, because some of the situations you get, they're not all able to be done by just simply counting up the number of ways. We've got to use mathematics to work out the number of ways things can occur. So one of the basic rules of combinatorics is that if you have two events, A and B, so if event A can be arranged or can be done n ways, and you've got another event B which can be done in m ways, then A and B, these two events, can be done in n multiplied by m ways. We multiply the two together. I'll put a little proviso here, and then this is if A and B are what we called independent, and independent is A does have no bearing on B. That's what independent means, that whatever happens in A will have no bearing on what will happen in B. So they're basically two events that are independent of each other. It may look a little bit like gobbledygook at the moment, but maybe just a quick little example might help you understand it. So if we've got some flights that go from Brisbane to Perth via Adelaide. So we've got Brisbane, Adelaide and Perth, and we've got 3 flights that go from Brisbane to Adelaide, and then another 2 that go from Adelaide to Perth. So the number of flights from Brisbane to Perth this is event A, Brisbane to Adelaide. This is event B, from Adelaide to Perth. There are 3 ways of getting from Brisbane to Adelaide. There are 2 ways of getting from Adelaide to Perth, and they are independent of each other. It doesn't matter which way you got from Brisbane to Adelaide. That will not affect which way you go from, or which flight you get from Adelaide to Perth. So the number of ways of A and B, of getting all the way through to Perth, so that's from Brisbane to Perth, is simply the 3 multiplied by 2. So there are 6 ways of getting from Brisbane to Perth. Alright, so that's basically it. You could sort of work them out. So we've got that one there, and then we've got 2, so that's 2 so far. And then another 2, that's 4, and then that one, and then those 2, that's 6. But by just multiplying, it's a much quicker way to do it. Alright, so let's just have a look at maybe a common occurrence with number plates. And say we've got number plates, and you want to know how many different number plates are available of a certain form. So number of number plates for cars, and let's assume, once again, that's a deadly assumption because you can get personalised plates, but we're just looking for the standard old number plate that has a number, a number, a number, and then an alpha, numeric alpha and an alpha, so a letter from the alphabet. So we've got 3 numbers followed by 3 letters. How many different number plates for cars? Okay, so the total number of ways we could make these number plates. I think it's, so we haven't got 2 events here. We've actually, like we had up here, we had A and B. We've actually got 6. So we've got that one, that one, that one, and those 3. So the way I like to do these is just by drawing the boxes and say, right, how many ways can I put down a number there? Well, I think you will agree there's 10. So we've got 0 to 9, don't forget 0, there's a possible number to go in there. We've got 10 there, and we've got 10 there. How many different letters could go there? 26, 26, 26. So the total number of ways is 10 times 10 times 10 times 26 times 26 times 26. And if you want to work that out, it would be 17,576,000. The total number of number plates that would be possible of that order. Okay, just another scenario, another type question. So, how many number plates could you make if you had no repetition? In other words, you can't repeat a number, so you couldn't have 3, 3, 5, so you can't repeat a number, and you couldn't have B, B, Z. All right? No repetition. All right, so let's just put our 6 boxes. Okay. How many numbers could we choose for a first number? Well, we're not going to get any repetition at all because it's going to be the first number. So we're going to put 10 numbers down. Now we don't want any numbers repeated. So this here, the second number, we can have 9 because 1 is going to be used there. This third number here, 2 numbers have already been used, so we can only have 8 there. Now here's my start of my alphabet ones, letters from the alphabet. We haven't used any letters over here, so we can have 26 there. We can't have repetition of letters, so I've used 1 letter there, 25, and then 24. So total number of ways is 10 times 9 times 8, and then times 26 times 25 times 24. So that's the number of ways with no repetition. What's the probability of a number plate ending in Z? Number plate ending in Z. And now with this example here, we're going to assume that repetition is allowed. So we'll go back to this first scenario here. So that's our total number of ways. So total number of number plates we can make is 10 times 10 times 10 times 26 times 26 times 26. That's the total number of number plates that can be made if repetition is allowed. Now, the top, how many number plates can we make that end with a Z? All right, so we could actually put our boxes down here. 1, 2, 3, 4, 5, 6. And if it's going to end in Z, there's no restriction on the numbers. So it'll be 10, 10, and 10. Now look at our letters. It has to finish with Z. So there's only one letter that can go at the end, and that's the Z. There are no restrictions on what could go there. You can have anything A to Z there, anything A to Z there. So that'll be 26 and that'll be 26. So this will be the total number of number plates ending in Z. This is the total number of number plates total, with no restrictions at all. This is the total number of number plates that end in Z. And you can see with this that things are going to cancel down. And so we get a chance of 1 in 26 that you're going to get a number plate that ends in a Z. That's provided that all the number plates are equally likely. And we're not thinking about being done in any order. So if to choose a number plate, if all number plates were all made, the chance that you picked out one that ended in Z would be 1 chance in 26. And when you think about it, that's pretty well stands to reason that there's going to be 1 chance in 26 that that last one is going to be a Z.